Okay, fine. It's a little late. Let's just get started. Welcome back to the final part of the Firefly build guide. It's been a long journey to complete the remote, but we're down to the last step. On the last part, we finished up assembling the last of the electronics, so now let's go ahead and get started programming everything so we can get riding. I've been getting lots of questions regarding the software setup of these guys, so let's go through this step by step. In part 1 of this guide, you should have grabbed the Arduino IDE, the Firefly firmware sketch, and Rolling Gecko's VESC UART library. However, there have been a lot of updates since the last part of this guide was published, and the documentation is kind of scattered. I stand by my recommendation to use the development branch of the code if you can, though. The receiver control code for it is far more refined and pleasant to use than the primary branch. A thing to note, however, is that you need to know which firmware your VESC is using. As of the latest update, the receiver code is only compatible with firmware 3.40 and newer. If you're like me and still on an older firmware version, you can download the code from one update earlier here. Now, in order to use the development branch, we're going to need a different VESC UART library than what was downloaded in part 1. So head over to Rolling Gecko's VESC UART page and change the branch to VESC 6 for older firmwares. For newer firmwares, you actually need to grab SolidGeek's version of VESC UART. Direct links for all of this will be down in the description. Now, you can install the new VESC UART libraries just like you did in part 1. And you'll need to grab 2 other libraries if you didn't already. You can search them like this. RF24 is used to control the radio boards, and U8G2 in order to control the OLED screen. Now that we have all the software we need, we'll go ahead and make a small change to make sure the remote and receiver connection is safe and secure from crosstalk. I used just a hex generator to get 10 random characters to insert into the pipe address. This will ensure your remote and receiver won't accidentally talk with any other rider's boards if they also happen to be using a Firefly. Make sure to leave the OX at the start and the LL at the end. Just copy and paste the 10 randomly generated characters in between them. This may not entirely be necessary, but the RF24 documentation has some mention about this being a best practice. Then, don't forget to do the same for your receiver. Now, we'll do a verification compile before uploading to make sure we're not missing anything else. Go ahead and verify the remote. The low memory error is totally normal for the development branch, so that's fine. Now, we'll go ahead and verify the receiver code. Both of them compiled successfully, so let's go ahead and plug in the Arduinos to program. You'll need to go to Tools, Part, and select whatever your USB comes up as. Mine shows up as Dev CUWCH USB serial 1410. If you're using the Robodyne Nano V3s from the part list, you'll also want to go to Tools, Processor, Atmega 328P, Old Bootloader. Then you can go ahead and hit Upload. Now that we have everything programmed, let's go into the Firefly settings. Hold the trigger and pull the wheel down while powering on the remote to access the settings. You'll want to set your battery configuration, motor poles, pulley information, and wheel size by scrolling to them and click the deadman switch to select them one at a time. Leave the control mode on PPM and UART if you want telemetry. Next up, we're going to calibrate the throttle. When you select a throttle value, a number on the bottom right will come up. This is the live reading of the Hall sensor input. Pull all the way to the back on the throttle and take note of whereabouts the number is bouncing around. Use the throttle wheel to set the min reading to about where it was settled. Next, we'll do the center value. Same procedure, select the setting, check the Hall reading while you're not touching the throttle, and then use the wheel to set the number as close as you can where the reading is bouncing around. Same procedure, select the setting, check the Hall reading while you're not touching the throttle, and then use the wheel to get the number as close as you can to where the reading is bouncing around. Last Hall sensor setting is the max. Same procedure once more. And again, I recommend setting your value slightly below the max so that you have easy access to the full throttle. You can exit the settings after that. Now that the remote is calibrated, let's move over to the VESC. Go ahead and power it on. Plug in your primary VESC if you're using dual VESCs like me, and open the software of choice for your firmware. You'll know if you're plugged into the primary VESC if its VESC ID is set to 0. If it's anything else, you're on the secondary VESC. Plug into the other one if you can. Or if you can't, you can press the CAN forwarder button right here in order to access the primary VESC from the secondary VESC's USB port. There's several different VESC tool softwares, but I'm using the Acmaniac's ESC tool. I'll try to keep these instructions pretty general, so just search around in the VESC tool you're using to find and set the following settings. First, we need to set the control mode to PPM and UART data. This lets the receiver control your speed and braking, as well as read the telemetry from the VESC. Next, we need to set the baud rate, which, from what I understand, is the speed at which the receiver and VESC will be communicating. If these aren't matched up, then the telemetry readings won't work. Set the VESC baud rate to 115200. With those two settings done, upload the changes you made, and then turn off the board. You can now go ahead and plug in the receiver once everything is off. Make sure you're plugging into the primary VESC. Turn it back on, and reconnect to your VESC tool. Now it's time to fix the neutral point and calibrate the throttle from the remote. In the tool, you should have a mapping setting where you can set a dead zone. Just keep bumping up the dead zone until it completely covers the variation at the remote's neutral point. Then you can push all the way forward, all the way back, and check the results in the mapper. If moving the throttle around looks well mapped, hit apply and upload your new settings. After it uploads, give it a test. Your Firefly and VESC should be paired. Throttle working with telemetry being sent. Thanks for following along with this lengthy build guide. Promise the next one won't take so long to make. If you enjoyed the series, make sure to drop me a like or a comment so I know to do more of these, or subscribe if you loved it. I've got Esk8 news every Friday and DIY projects going up every week too. Till next time, toodles.